We already had it. No one else. We didn't have one.
We had them on beaches. We didn't have one on.
Why did she give us two? It's okay.
You guys ready? All right. After checking the homework, guys ready to get going? Olivia, may I start, please? Thank you. Appreciate that. All right. After checking the homework, I want to talk about 8. Right? Let's talk about 8. Right? All right. I can't scroll down right now. Or just like on number 8, you're saying?
No.
Oh, I had it over there. Did I not freeze it? Oh, well, that's my bad. Hold on. All right, we'll get to 7 in a second. All right. Hey, guys. Let's go. All right, 8. Let's take a look. So when they told us WX is congruent to VZ, that's that pair. Then we had WY congruent to VY. Did anyone have an issue as soon as they told you that? You're like, that doesn't seem right if I'm trying to prove that VWX, this triangle, do you see how that triangle right there at this point, I can say, that green segment, that's not a whole side of that triangle. You see what I'm talking about? They told me the red ones were congruent. I'm good with that. WX is the side of the triangle. And I can see the reflexive property. There's an overlapping side. I bet everybody saw that, right? After doing the example in the notes yesterday? You should. All right. But the problem is this green segment is not a whole side of that triangle. Red flag. All right. So we'll talk about that in a minute. Let's keep going with the givens. We have WY congruent to VY. I have that in green. And then YZ congruent to YX. All right, so at that point, I'm thinking, wow, it takes a green and a blue to make up a side of that triangle. Do you agree with that? It takes a green and a blue to make up the whole side of that triangle. So this is where the book says, maybe redraw it. Maybe take WVX and kind of pull it over here to the side. I'm going to run out of room. But then take, what did they name it? WVZ. And pull it over here to the side. And then kind of label the parts that you know are congruent. Well, I think we all agree with the reflexive property. We have these congruent. With the given sides, these were the red ones right here. I said red. Red. Those have the triple tick marks. So as we make this plan for the proof, I think the problem lies with that third side. Agreed? And what does it take to make up the third side? It takes a green and a blue. It takes WY plus YZ to make WZ. Ooh, that's from chapter 1. You remember what that's called? You have a little hint. It's down there in the statements. What's it called? The segment addition postulate. That was kind of mean, wasn't it? It's kind of mean. Do you see how it takes the segment addition postulate to get the whole side length of that triangle? Even if you didn't get it on your own last night, or early this morning when you tried your homework, or right before the bell rang. Yes? You know you are. It took the segment addition postulate. Oh no, we're calling people out by turning around looking at them. The test Levi. Yeah, we knew Levi, but.
And this is second period. Like no one. It's the same thing.
All right. So that was probably the tricky part. All right, back on task. It took the segment addition postulate to get WZ and VX. And then you could have said substitution there, or transitive property is fine as well, to then say those corresponding sides are congruent. All right? That was 8. some of you, apparently I didn't freeze the screen properly, so you didn't get to check the bottom ones. There's 7. Here's what I would say with number 7. If you're not getting some people left 7 blank, and I'm not trying to hurt your feelings, but if you didn't get 7, okay, you need to reevaluate effort level. Okay, I'm not trying to be mean. I'm just being honest. Okay, you guys need to. There was one step in that one on your own. Okay, and it was the reflexive property. Page.
For number 2, step 2, wouldn't it be LJJL?
Wait, where are you?
7,
Step two.
2 says JL. I put LJJL because
I agree. The book has it wrong. Yep. And they wrote the congruence statement right, like LJJL. Okay. That was not pinky to pinky. Who's going to write a letter to the publisher? Levi, you're not going to do it. Leah, you're going to write a letter to the publisher. Tell them they're wrong. Levi, I'll be nice to the rest of the period. All right. Check the rest. Don't forget, when they tell you that 2 segments are perpendicular, it takes a couple steps to get from perpendicular to that they're congruent.
Where did you get AD from? I guess that.
And by the way, we do things a little different than they do. So on this proof, here's some alternative options.
The proof is duplicated. Yeah.
Hold tight.
Publisher sucks.
No, actually, this is my fault. I'm gonna take the one first.
What?
So here's what I did. When they did it, I captured it and I put it on the wrong one. Hold on a second. It was like way down here, and I knew I wanted to be able to scroll and have you guys check both screens at the same time. So I like recaptured it and moved it up. That one, that one was fine. It was the other one. It was this one. Yeah, they had it was taking up way too much of the page. You weren't able to see both the proof and the picture at the same time very well. All right. As I was saying on number 11, an alternative proof. Are you ready? If they tell you AB is perpendicular to AD, AB perpendicular to AD, you say they're perpendicular, then you can say they're right angles, and then you can say they're congruent. Okay? I have a little bit of an issue with their proof here. They said they're right angles, but they never said they're congruent. And do you remember they emphasized early in the book that all right angles are congruent by the right angle congruence theorem? And so they really, if they were going to be thorough, they should have said step 3, they're right angles. And then step 4, they should have put angle BAD is congruent to angle CBA. Here's what I'm going to say, just so you understand what I'm looking for when I'm grading. If you say HL, and I'm going to back up. I'll tell you what, I'm going to take a couple steps back. I'm going to give them a pass on that one. Here's why. HL is a little bit of a different case, okay? We're not actually proving the right angles are congruent. We're saying that the triangles are right triangles. Let me say it again. In HL, what do you need for HL? You need right triangles that have a pair of legs and a pair of hypotenuses congruent, okay? Do you agree? So in HL, we never actually use SAS, like a pair of angles are congruent. We just say they are right triangles. So I'm going to give them a pass on that one. All right. They said that we have right angles, therefore they're right triangles, and they have a pair of hypotenuses and a pair of legs congruent. In other proofs, like SAS, I have to see a pair of S's, a pair of A's, and another pair of S's. Okay. But here, the right angles were only used to classify it as a right triangle, not as a pair of congruent angles. Do you understand what I'm saying there? I know it's kind of a weird example, but that's a situation. Number 12, I would say, is a very straightforward proof. Okay, number 12. We see triangles that are, we're going to have a couple options on this one, by the way, eventually, not today, but maybe later today, at the end of the period. G is the midpoint. Okay, G is the midpoint, segment, congruent. Did you notice it didn't say, check your work, did you put that these two segments are congruent, IG and FG? Did anyone put those are congruent by a midpoint? Because you saw that on your last quiz. You saw that a point was a midpoint of two different segments. That's not the case here. G is the midpoint of just EH. Do you understand that?
Yes.
Is that always the case? Is G always going to be the midpoint of both? If it's the midpoint of one? No. Tell me.
But isn't G still the midpoint of FG and GI?
It is, but not because they told us that. Like, they didn't say it's the midpoint, but they told us, oh, the segments on either side of it are congruent. Oh, it must be a midpoint, right? So, yeah, we came to find out that it's a midpoint of that one too, but it doesn't have to be always. All right, well, we got that. We got E and H are right angles. That means they're congruent. And we're out of givens. Did anyone use the vertical angles theorem here? No one. No one used the vertical angles theorem. Did you at that point recognize HL? I'm only saying like two nods.
Yes.
At that point, you recognized HL. Good job. Well done. So the right triangles, a pair of hypotenuses, and a pair of legs are congruent. You can stop. You have HL. Could someone say vertical angles and then SAS? Yeah, I'd accept that. And by the way, if they didn't tell us that these are right angles, that would have been the only way to do it. Okay? Was SAS. But they told us that was the case. All right, let's get into our notes today. We have our last two triangle congruence theorems, ASA and AAS. They both have two A's and an S. So what's the difference? All right. I'm going to give you two pictures up here. I want you to, don't blurt it out, just think. I want you to think about them, look at them. One of them's ASA, one of them's AAS. I want to know the difference. Just think. In math vocabulary, we'll earn you extra cool points. Okay, who wants to? Paige, what do you think?
In the first one, it's ASA because it goes angle, side, angle, which means the side's in between the angle and the other angle.
Good. And the other one?
And the other one is AAS because it goes angle, angle, side.
You guys agree? Is that what you're going to say? In your mind?
I was gonna say the hypotenuse and then the leg, and there's two different sides.
Yeah, let's pretend you didn't say that. There's no hypotenuse in this one. All right.
It's right there.
Those are arcs. If these look like right angles, they're not supposed to be. They're arcs. Huh? Yeah, we can't go off of looks. Can't go off of looks. All looks like it's right. Yeah, you guys all look like you're paying attention, but we know that's not true. All right. ASA, like Paige said. Now, we have a key word. She used the word between. If you want to get really nerdy, you can use the word included. Two angles and the included side. Ready? Two angles and the side that goes between them. So important. So important. Two angles and the side that goes between them. A couple fill-ins here. Ooh, these are out of order, aren't they?
Yeah.
This is your second one. This is your second one. Oh, come on. I'll get over it.
I'm gonna be confused. I was already confused.
This is Emma, by the way. She's shadowing today. Do you want to go back on this? I had her last year. She graduated last year from Lake. She's going to college at Benedictine in Kansas.
Yeah.
Kansas. She's home for Thanksgiving. She wants to teach. Please don't convince her otherwise. All right, are you guys done complaining about me putting these out of order?
No.
Do you need to get out of your system? Here, I'll change it so sixth period doesn't complain.
Oh.
There.
No, keep it that way.
Ready? AAS. AAS. No, I put them out of order. Technically, they're both at the top of the paper. I didn't really have them in any order.
Oh, one's on the left and one's on the right.
Very good. Hi, Mackenzie.
Hi.
You okay today?
Yeah.
Ready for Thanksgiving?
Yeah.
Me too. All right, angle, angle, side. Angle, angle, side. You'll see words like two angles and the non-included side. The non-included side. So a quick question for you. See this tick mark right here? If I move the tick mark to over here in purple, is it still AAS? Ignore this tick mark.
Yes.
What if someone said, no, that's SAA?
You can flip it over.
Good. AAS is the same as SAA. Okay? Just like ASA is the same as. No, I said ASA. What's it backwards? Good. All right. It's all about the emphasis. All right, next. Let's see if we can identify if they are congruent by what's marked. Now, these are kind of hard to see. The triangles they're looking at here are this one. Black's not a good choice. Let's use yellow. This one and this one. They told us these arcs are congruent and these sides are congruent. Can the triangles be proven congruent with the information in the diagram?
Yes.
What do you need to do first? Vertical angles, good. And then we have, which one's that? AAS, perfect. We're going to go through these quickly. It is on your paper. Next one, we see 3 sets of angles congruent in both triangles. AAA is not one of them.
Oh yeah.
Ooh.
Doesn't matter.
Let's talk.
Wait, if there angles are
All right, let's bring it back together. I hear some comments like if their angles are equal, their sides are equal. Ooh, I'm gonna go nerdy on you. Are you ready? There was a time when we graphed these on an XY axis. Thank you. You're welcome. A, B, C was dilated by a scale factor of 2. B prime. C prime. A prime. Same shape?
No.
No.
It's not?
No.
Not
It's
even
like
Yes, it
A is in the
Dilated.
same position, Y axis.
Wait a minute, guys. Wait a minute. When you dilated triangles or any figure, it kept the same shape. It was just a different size. Right?
Yeah, but
But
your
that
A
doesn't-
Hold on, one at a time. Tyler, go for it.
Oh, your A has the same Y value as the original A. So
No, it's down a little bit. See, I was talking about the outside. Levi!
Either A should be like further left or C should be further right because you made it look like an equilateral. It's like
Hey guys, I didn't use a yardstick or measuring tape or anything. Pretend these are dilated.
So they're like.
About the origin.
So they are.
Okay. Do you remember how it was on that line of dilation? It was just farther out, right?
Yeah.
McKenna.
Can I use the restroom?
Yeah. Are they the same shape?
Yes.
Yeah.
What does same shape mean? And I'm not talking about a change from a triangle to a pentagon. Same
Angle.
angles.
You're welcome. The one thing. Yep.
But this one,
It's bigger.
the sides are double
Longer.
this one. Are they congruent?
No.
Besides? No.
Are these triangles congruent?
No.
Yes, they are, Tyler.
These triangles are congruent. They're not congruent.
What?
So,
Oh, the angles are congruent. I thought that's what you were saying.
is a congruent theorem?
No.
No. Because they could have the same angles but be different sizes. Right? Tell.
Can't you use that C? I don't know how to spell it out.
CPCTC.
Can't you use that for that? Because if the angles are all the same, then the sides have to be all the same.
But they don't. I just showed you.
I don't know. I think I misunderstood.
I know what you mean though. How is CPCTC being confused a bit? What does CPCTC stand for?
All congruent sides.
Not even close.
When two triangles have two congruent sides.
So corresponding parts.
Alright,
Alright, quiet. Corresponding parts of congruent triangles are congruent. Okay, now, here's the problem. If someone didn't silence their phone. Corresponding parts of congruent triangles are congruent. Alright? Now, here's the thing. Our English skills are holding us back just a little bit. What are congruent? And I'm not being mean. It's just it's out of order in what you guys are used to. Ready? Corresponding parts. Those go together. Do you agree? Corresponding parts are just words that are attached. You can't separate those, right? Of what kind of triangles? Congruent triangles. They're attached. Are congruent. Okay, what is that congruent talking about?
everything, the whole thing.
No. It's talking about the corresponding parts.
Good job, Jared.
This congruent is talking about the corresponding parts. It's our English. It's the order that's holding you back. Ready? Let's do it again. Corresponding parts of congruent triangles are congruent. What's congruent? The corresponding parts. Of what kind of triangles? Congruent triangles. Do you see how we're not used to reading English sentences that way?
Yeah.
Yeah.
Corresponding parts of congruent triangles are congruent. If we were to rewrite it however we wanted to, we would say, see those parts that go together? Yeah, if those triangles are congruent, those parts that go together are congruent. Okay? Yeah, but we don't want to write that out. Right? But here's the deal. Tally said, if the angles are the same, aren't the sides the same because of CPCTC? But what do we have to do CPCTC? And these congruent triangles only come from SSS, SAS, ASA, AAS, and HL. So you can't use this until you got into one of these. And so do you see how we don't have SSS, SAS, ASA, AS, and out, right? So this one, not enough information. No. All right, we need to really move now. All right, can you guys see the picture here? Can you see this? Okay. I have a single arc mark here and here. I have double arc marks there, and I have two triangles that are attached, sharing a side. Reflexive property. So are these two triangles congruent? By? I hear ASA. Do you agree? You disagree? Okay, this gets confused a lot. Put the pencil down for just a second. Watch. Watch here. See this triangle? When you're deciding ASA, do not hop between the triangles. Stay in one triangle at a time. Okay, I'm looking at the green triangle. A, S, A. Now I ignore the green triangle. I'll look at the other one. A, S, A. Yeah, ASA. Do not hop on either side of the triangle. Do you see how students could do that?
Yes.
Yes? Okay. Did you say you don't know? Huh?
Yeah, pretty much.
All right, moving on. All right, this letter A. Are these triangles congruent? By? I agree we have a pair of hypotenuses congruent. I don't see any pair of legs congruent. If you're told G is the midpoint of EH, I would agree with you. If you were told G is the midpoint. Are we told that? No. What else? Thank you. Vertical angles. Vertical angles. Every single time in your life, from here on out, I've told you, when you have triangles that are point to point, vertical angles are going to be congruent. So which one's this? AAS. I agree. AAS. Next one. Well, I see reflexive. They're a linear pair.
So,
Does that mean they're congruent?
yes.
Yeah, it could be 120 and 60. It could be 90 and 90, but we don't know that. Is MQ an angle bisector? We don't know. We don't know. Not enough information. I think you probably have issues with that one. I bet you don't like that. Tally?
What was A again?
Letter A? Oh, I didn't write it down. Thank you. A, S. Do you guys see that that's A, S, letter A? Go ahead.
I don't see how it's AIS. I'm sorry.
Angle, and the side not between them. Angle, and the side not between them. All right. Next, McKenna.
Wait, never mind. I figured it out.
Next one. Thank you.
ASA.
You guys agree? ASA. All right. Let's try a proof. All right. AD is parallel to EC. I'm going to go ahead and write both givens on the same line. BD congruent to BC. Given. Parallel gets marked with an arrow. And the BD congruent to BC gets marked with tick marks. Question for you. Does parallel count for S in SAS or SSS?
No.
Or AS? No, it does not. What do we talk about though? I warned you. if you see parallel lines, consecutive interior, corresponding, alternate exterior? No, alternate interior, right? That's the only pair that are going to be congruent. And we talked about making that Z. You remember that? Making the Z to see which angles are congruent. All right, so let's think about this. Who's brave enough to name the pair of alternate interior angles that are congruent? Let's hear from some new people. Who's brave enough?
Nope.
Christiana, you got this?
A, E, and D, C.
A what?
C.
Angle A and angle C?
No, A, E, and D, C.
Those are segments. What are congruent by alternate interior angles? Let's help out. Levi!
Okay, I don't know if this is right, but
I don't either. Let's go for it.
ADB and
ADB is right here.
BCE.
I'll give it to you. Yeah. If you go, I'm going to be kind of picky, but not really. If you said ADB, you'd have to say ECB because of the corresponding order. But you named the right angle, so I'm giving you a gold star for today. Oh, you're welcome. Now, I know Levi. He doesn't want to write any more than he has to. Okay? So let's help Levi out. Does he have to name it with 3 letters in this case? No. Because there's only one angle at the vertex. So angle D is congruent to angle C. Reason? Alternate interior angles. All right, now let me help people out. Here are the parallel segments. Levi used this transversal. Do you guys agree? You see the green Z? He used those alternate interior angles. In a moment of brilliance, could Levi have said, you know what, Mr. Westphal? What if I used that transversal? Are the other pair of alternate interior angles congruent? Yeah, Levi, that's brilliant. All right? Now, I'm going to give you that option. You could have also said angle A is congruent to angle E. Alternate interior angles. You guys want to mark it? Are we there yet? Are we ready for step to say that they're congruent?
No, we have vertical angles.
Yeah, we have to
Oh,
choose
no.
the angle.
Levi he doesn't want to do any more work than he has to. Huh? Okay, so if you wrote vertical angles, you're fine. We'll get to that in just a second. Do you agree, though, right now with what's marked? We have AAS. So triangle ABD is congruent to triangle EBC. And apparently I can't count.
Yeah. Give a 4 for number 3.
Thank you. I appreciate you guys and how gentle you are with criticizing me. AAS. Now, another student, ready? Because I have to grade these. Another student didn't do both sets of alternate interior. Not everybody can be Levi. All right? Ready? What if they did this pair of alternate interior, they had this pair of givens, and they did vertical? They did one pair of alternate interior, and they did vertical. They would not say AAS. They would say ASA, and I have to count both correct. All right? Because both are fine. So if you put vertical angles, I would count it wrong if you put AAS. If you put vertical angles and you did ASA, that's fine. But wait, another student, yes, they saw these alternate interior, but not those ones. They saw these alternate interior and vertical angles. They would have put AAS. Do you see it? AAS. A, and the S not between them. AAS. Do you see it? Be honest. Okay. Do you see how there's different ways to do these? Beautiful. All right. Next one. AB. Perpendicular to AD. DE. Perpendicular to AD. And AC. Congruent to DC. Insert AC/DC joke. All right. AC, DC, perpendicular, perpendicular. Yes, Emma. Yes. All right, we need to make a plan. Do you remember how I kind of criticized the book for the way they answered one of the proofs? And I said they never said this right angles are congruent. That was okay because they chose to go HL. But do you also see how right angles could sometimes be counted as an A in AAS or SAS or one of those? Yes? In that case, you would have to say they're congruent. We kind of have to chart out our path before we start. Are you ready? With what's marked, what's the easiest way to do this? Is HL an option? It's possibly an option. Let's look at it though. Where is the H's? The hypotenuses. BC and EC. Can we say they're congruent? Because if we can't say the hypotenuses are congruent, we can't use HL. We can't. We're not told C is a midpoint, are we? We're not told they're congruent. What are we going to have to do? McKenna. Triangles are point to point. What are we going to use? Good job, McKenna. Vertical angles. Do you agree? These vertical angles are congruent. Vertical angles. So that's an option. And if we do that, these triangles are going to be congruent with ASA. But we got some work to do first. Okay, we got some work to do. Step one, we said that segments were perpendicular. We need to say that they're right angles. All right? Angle A and angle D are right angles. That's the definition of perpendicular. Definition of perpendicular segments. And because we're using it in ASA, we need to say angle A is congruent to angle D by the right angle congruence theorem. Angle ACB is congruent to angle DCE. That's a C. Vertical angles. So the triangles are congruent by, I'm going to run out of room or time. Step 5, the triangles are congruent by A, S, A. Yes, does that make sense? All right, your homework. Are you ready? You're gonna do this one on the proof, on the guided notes. This proof. This proof on the guided notes, and I'm gonna cut your homework back a little bit. What's up? Oh, don't look. Don't look. That's a surprise. You're welcome. Hey guys, I'm gonna make you a deal. Are you ready? You're gonna do those 2 proofs from the guided notes, and I'm gonna take these 2 proofs off of the homework assignment. Okay, that way you don't have to write them out again. They're on your guided notes. So you guys are doing 2 through 8 even, 13, and the 2 proofs from the guided notes. Those are just, are these congruent by whatever? Yeah.